So I'm going to scaffold how I'm going to use the undetermined coefficients to solve this equation. So in general, we have four steps to solve this one. So it's very easy to recall. The solution form, it should be in the YH plus YP. So first of all, step 1, we want to get a homogeneous solution first. So it's very easy. I just make the general equation, the equation given here, to become equals to 0 first, and then I transform to the characteristic equation, and this is where I go. Here I have this. So once I have this, I'm going to solve these equations using the formulas for the quadratic equation, and this is what I have here. And then I'm going to solve this, and so this is what I get the y1, m1, m2. So for m1, m2, and based on the m1, m2, so this is the real and distinct roots. And from the table, from the previous table, so this is what I get the YH. So it's very easy. So now we proceed for the second step, but this one we're going to use in the step 4 later. So step 2, now we're going to find the YP based on the fx that we have here. So this is the general solution that we have here, and we know here this is my fx. So for my fx, I want to know the alpha. So my alpha here is equals to alpha 3. So how I get this alpha 3? Basically, you look at this one. So basically, this is referred to your fx, and this is referred to your yp form. So for your fx, and this is the alpha x. So that means this is the alpha equals to 3. So that means this is what I have here. So once I have the alpha equals to 3, so what I'm going to do next is I'm going to compare with the roots that I have on the previous step. So I found that the m1, m2 is not equals to 3. The roots is not equals to 3, so that means I'm going to choose this one, choose this row as my solution for my YP. So this is what I get here. So because of alpha x, that means this is alpha, I just putting inside, and this is how I get the solution. I'll be using this for the step 3. So step 3, I'm going to differentiate for y prime and y double prime p, and this is somehow I get this one. So it's very simple. I just start from this one, I'm going to differentiate this, I get this one, differentiate again, I get this one. So I'm going to use these 3 things to get for the constant. So I'm just going to use this one to substitute to the equation in its given equation, and this is somehow the given equations. So what I did here, I'm going to substitute one by one. So which means this one y double prime I'm going to replace in this one, y prime p actually I'm going to replace in this one, and yp I'm going to substitute in this one, so the y here, and then so this is somehow I get a solution. And once for this one I'm going to simplify, so this is what I get here. And when we notice that this is the exponent 3x, this means we can just do some cancellation or simplification, equals to 1, and this is somehow I get this one, and this is the c. So when I get the c values, so what I did here, I'm going to use this substitute to the original yp here, and this is somehow the solution that I get. And this is the yp, and then we proceed for the step number 4. That's when we're going to use the yp and the yh on the step number 1. So this is the solution form, it should be like that. So the solution form, it should be the yh plus yp. So this is my yh and plus with your yp, and this is somehow you get a solution. And it's very simple for this one. For more details, you can try to do some study on this chapter, or do the exercises in the tutorial.